Venus, the second planet from our Sun, sitting at average of 0.7 AU. Venus only has an axial tilt of 3 degrees, giving no noticeable seasons. The planet appears to be white from space due to its thick atmosphere of clouds that reflect and scatter light. Down on the surface, temperatures reach up to 471 degrees Celsius due to such an intense greenhouse effect. This is hot enough to melt lead. With such high temperatures, Venus makes her mark as one of the hottest places in the solar system. Besides temperature, Venus is very similar to Earth. It has many mountains, volcanoes, craters, and lava plains. Rocks on the surface are gray, but the atmosphere filters sunlight in such a way that everything appears orange. However, the surface is covered in dust. Venus also has some pretty impressive features, one of which is Maxwell Montes, Venus's tallest mountain, rising 8.8 kilometers above the surface, an impressive size considering Mount Everest is 8.85 kilometers. Venus has a very thick atmosphere. The atmosphere is mostly composed of carbon dioxide, but also contains nitrogen and sulfur dioxide. The clouds are made up of sulfuric acid. At 50 kilometers, Venus's atmosphere is very similar to that of the Earth. Temperatures cool off to about 75 degrees Celsius. Pressure is also 1.05 atm with 89% of Earth's gravity. Venus also receives more solar radiation than Earth, but has slightly higher radiation protection due to the very thick atmosphere. Compared to Earth, Venus is slightly smaller. Venus has a radius of 6,052 kilometers, where Earth has a radius of 6,371 kilometers. Venus rotates backwards compared to Earth and the other planets. However, it is very slow, causing slow wind speeds. It rotates so slowly that it takes Venus longer to complete one full rotation on its axis, or 243 Earth days, than to complete one orbit around the Sun, 225 Earth days. HAVOC is a future mission to inhabit Venus, an acronym standing for High Altitude Venus Operational Concept. HAVOC would be a 30-day crewed mission to Venus's upper atmosphere. HAVOC was proposed by a group of aerospace engineers from NASA's Langley Research Center in Hampton, Virginia. NASA says a lighter-than-air vehicle could carry either a host of instruments and probes or a habitat and ascent vehicle for a crew of 2 astronauts to explore Venus for up to a month. Such a mission would require less time to complete than a crewed Mars mission. There would be difficulties to the mission. An internal NASA study in 2015 identified several key technical challenges: performing the aero capture maneuvers at Venus and Earth, inflating the airships at Venus, and protecting the airship, especially the solar panels, from the sulfuric acid. The HAVOC mission intends to understand how Venus's atmosphere formed and evolved, understand the radiative and dynamical energy balance on Venus, learn more about Venus's clouds, determine if habitable zone on Venus's atmosphere harbors life, determine whether Venus ever had surface or interior liquid water, and what role the greenhouse effect had on the climate throughout Venus's history, learn how the interior, surface, and atmosphere interacted as a coupled climate system over time, determine how Venus is releasing its heat now and how it is related to the resurfacing and outgassing, and learn more about Venus's surface. HAVOC will be very similar to Mars 2020. Similar technology is required, such as long-duration habitats, aerobraking or aero capture, propulsion requirements, and carbon dioxide processing. Thus being said, HAVOC would be a faster trip than Mars 2020. The trip to Venus would only take about 100 days compared to about 200 days for a trip to Mars. When originally proposed, HAVOC was thought to be a possible stepping stone to Mars 2020. HAVOC will be broken down into 5 phases: robotic exploration, a 30-day crew to orbit, a 30-day crew to atmosphere, a 1-year crew to atmosphere, and permanent human presence on Venus. Phase 1. Robotic exploration. Before any human presence begins, robots will be sent to explore the area. NASA would like to learn a little more about the conditions before astronauts are sent to the planet. We have already seen some Venusian exploration with the Soviet Venera series, Pioneer Venus, and Magellan. Phase 2. A 30-day crew to orbit. Next, a crew will be sent to orbit for Venus for 30 days. Before actually entering the atmosphere of Venus, a crew will orbit the planet for 30 days. This phase is mostly to test out a new technology that will be used to send ships to the planet. Phase 3. a 30-day crew to atmosphere. This is the biggest part of the mission, the first actual time a human will live on Venus. This phase will be used to test the effects of Venus's conditions on both the astronauts and the spacecraft. It is also to test the new technology that will be used to maneuver throughout the Venetian atmosphere. Phase 4, a 1-year crew to atmosphere. Next, we allow a crew to live on the planet for a year. This is where extensive research of the planet will take place. The crew will run experiments and conduct studies to learn more about the planet and its atmosphere. This will also give more data on human health under the Venusian influences for a longer period of time. Phase 5, permanent human presence. Finally, we reach the end. Phase 5 is when humans will finally inhabit Venus. Humans will permanently live on Venus. By the time Phase 5 is started, the Mars 2020 mission will most likely be well underway, and the human race will officially inhabit 3 planets. It might be well on the way to inhabiting Mercury from space shuttles leaving Venus.